Now that we've started looking into how to conduct an experiment with the elementary school students, and we gathered the data, now let's take a look. Part 2 of, or section 2 is displaying the data. So we're going to be doing this in 2 parts. Now, one thing I recommend, if at all possible, print out the examples that are in the module from 10.2. The reason is there's going to be a whole lot of data information, and if you have a capability of printing, then you can sort of, after we go through some brief notes, then the examples that I've printed out, you can spend the time answering the questions instead of having to write the questions. If you don't have access to a printer, then what I'm going to do is, when we get to the examples section, I'm going to pause the video, write the example, and then go from there. So you too can then pause the video, write the examples down, and then continue with us. Okay? So first of all, when we're displaying data, there's all kinds of ways to display the data that we collected in our experiment. So ways to display the data. Now, when we say it's an experiment, we're talking about a simple experiment, simple meaning 1 or 2 steps for an elementary school classroom. So one particular way is by what's called a pictograph. And a pictograph is a picture that represents what we're talking about. So it's a picture of a graph. So instead of numerical values, there's a symbol to represent the data points. Okay. So it's kind of like a picture of a graph. Now we also have what are called dot plots. Okay, dot plots or line plots. And we're going to have examples of all of these. And the examples are already printed and they're a PDF in your module. So within these dot plots, which is a line made up of a bunch of dots or little X's, we're going to be looking for things like outliers. And I'm going to show you how to calculate outliers. These are data points that are significantly higher or lower than the majority of the data. Higher or lower. Okay? Than most of our data. Okay, so now we're also going to take a look, other than outliers, we're going to take a look at clusters, which are also found on dot plots or line plots, which is, clusters are just kind of what you think of. It would be a whole group of, isolated group of points. So sometimes you see things clustered together. I use dot plots when I'm looking at overall grades for a test or quiz, and you'll see that when I give you an example. So these are isolated groups of points. And then sometimes we have a gap, which is pretty much what you think it might be. It's a large space between data points. Yeah, sometimes it's a large space between clusters. Okay, and then oftentimes and we will get into mean, median, mode, but we want to talk sometimes about data points that happen the most often. Because if you're giving, say, a test and you want to look and go, well, which score was the one that occurred the most? Because that gives you a lot of information about your test. So something, just a little side note, and we're going to go into it more later. Mode represents the data point occurring most often. All right, so we've talked about pictographs, dot plots. We also need to take a look at a frequency table. And we saw some of those in the last section. It's a frequency table displays the data, the number of times the data elements occur. So it's a table the number of times a data point occurs. So in the last section, we talked about the question you might ask a kindergarten class. How many pets do you have in your household? And the table of student number 1, student number 2, student number 3, that table would be a frequency table. How often or how frequent did it happen? Okay. I need a little more room for the next one. So the next one we're taking a look at is, we referred to a stem and leaf plot. And a stem and leaf plot orders your data. So it has the data written from the lowest to highest or the highest to lowest. Okay, so it orders data in a 2-column table. So it ranks it. Either it ranks from low to high or high to low. So it ranks your data. And within a stem and leaf plot, you can have a back-to-back stem and leaf plot. So we'll look at one of those two. So you could have what's called a back-to-back. And this might be where you are comparing two people for the same task. So you can compare their data side by side. Okay? So perhaps I might use it for, I have 2 classes of math analysis, so perhaps I want to compare 3rd period's results to 6th period results. I can put them back to back. So we use this when we're having, we're comparing 2 similar sets of data. And we have also what's called a grouped frequency table. And this might be, a grouped frequency table shows how many times data occurs in a particular range. Shows the number of times data points occur in a range. Okay. Then we have a histogram and bar graph. And sometimes you can have a double bar graph. But histograms, these are created from a frequency table. Both of these, histogram and bar graph. They're created from a frequency table, or they are created from a dot plot. Or they're created from stem and leaf. Okay. Okay. Then we also have, well, a bar graph, which is part of that histogram, as far as I could have done them separately. A bar graph we looked at the other day, it's similar to a histogram, but it has spaces in between. So I'll give you a little picture here in just a second. A bar graph is similar to a histogram. But this one has spaces between the bars. So for example, I'm going to draw a little picture here. Okay, we talked about a bar graph last time. So we did a single bar graph and a double bar graph last time. So, and double bar graphs can also be, whether it's a single or double, they can be created from each of these, a frequency table, a dot plot, a stem and leaf plot to get our data. So when you have a bar graph, you might have a single bar graph like we did with how many students had or another, how many pets are in the household. Then we changed it to what kind of pets are in the household. So for one student, a double bar graph or a triple bar graph. That's where we had the fish, the dogs, the cats, etc. So kind of give you just a visual, and then we'll look a little bit more. A histogram might look like this. You might have your axes, where you've labeled your axes, and I'm just going to kind of give you a picture. And you say, okay, maybe this is going from 1 to 2 to 3 to 4 to 5. And a histogram might say, all right, I have 2 items that are going from 1 to 2. So you've covered that, and you've said, okay, it covers this range. That's what we mean by a grouped frequency table. It covers the range. But then from 2 to 3, maybe this is how many people on the playground. From 2 to 3, maybe this number jumps. And so during that entire range, perhaps we have this number. But then from 3 to 4, it drops down. And so maybe I have something else. I'll go this way. And then maybe from 4 to 5, it looks something like this. So notice they're all connected together. So with a histogram, they're all connected together. With a bar graph, if I have 1, 2, 3, 4, and I have some numbers going up the side, the bar graph was not connected, and it spanned this person number 1. And then we had a space, and we went to person number 2, and then maybe we have a space. So there's a space between each of the bars to give you kind of an idea, okay? And then the last type of information we might have is a circle graph or a pie graph. So we have all kinds of different ways. And pie graphs with the young ones, kindergarten, first, second, you would need to probably have them learn how to read the pie graph. When they get older and they can use a compass and a protractor, then we could actually have them calculate and create a pie graph. So it's either called a pie graph, pie chart. It's actually called, I've got this backwards, the actual name is circle graph. But most of the time we refer to a pie graph. So it's actually called a circle graph because you are organizing this and displaying this data in a circle, but sometimes you hear it as a pie chart, a pie graph. But technically it's a circle graph because you're creating a circle. And what happens is this circle is broken into wedges that represent which part or percentage. Representing a part or percentage of the whole or the entire data set. Okay? So what we're going to do is we're going to learn how to make and do each one of these. So I'm going to pause this while I set up the first example, and we'll go through how to do each one of these in this section. Okay, now if you need to pause and write these down because you haven't printed them out, here are the first two examples. Here's an example of a pictograph, and a pictograph, remember, is a picture representing data. So this is very helpful for the youngest of our classes, but it's actually a great way to just draw a picture. So in the first case, a teacher asked all of her students in class how they came to school in the morning. And the following pictograph is the findings. So use the picture graph to answer the questions. And notice there's always a legend. A legend just tells you what each of these, I tried to make kind of little stick people represent. So each of those little stick people represents one student. So as we walk through that, how many students arrived by bus? Well, since each person only represents one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure that's the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like there are 10 students that arrived by bus. How many students arrived by using a bicycle? Well, it looks like a bicycle, we have a total of 5. How many more students? So now the students have to compare. How many more? So now they've got to know the difference between more or less. How many more students come by car than by bike? Well, if we go ahead and count these up to begin with, 1, 2, 3, 4, 5, 6, 7. So how many more students come by car than by bike? So they're getting a number sense, recognizing hopefully that 7 is 2 more than 5. So this is a great number sense problem. So how many more come by car than by bike? 2. And again, number sense. How many fewer come by car than by bus? Well, car has 7, but bus has 10. So there are 3 fewer people because 10 minus 7 gives us 3. How many do not come to school by bus? So if it's not by bus, then this gives us an opportunity to talk to them about, okay, if it's not by bus, what is it? Well, if it's not by bus, it is by car and bike. So car equals 7, bike equals 5. So there's a total of 12 that come by not bus. And then finally, how many students are in the class? Well, according to the original example, the teacher asked all the students. So all the students are made up of this selection. So our total would be 7 plus 10 plus 5. So our total is 22 students. Okay, so maybe this pictogram didn't have people that walkers. That's what I mean by picture graph. Now a dot plot, and the example of a dot plot I gave you, or sometimes you call it a line plot. And the reason we call it a line plot is we've got our line that represents our data. And I do this visually with quiz grades or with test grades. I put on here, like say we had a quiz that went up to 40 and these were the scores, then I would draw little dots or X's to represent the scores. In this case, each of these dots, the dot plot represents the fuel economy in miles per hour of 2015 model cars. So in one car, it only got 16 miles to the gallon. Here's one that's between 22 and 24, so we call it 23 miles to the gallon, 27 miles to the gallon, 30 miles to the gallon, so you kind of get the idea. So let's start off with how many cars are in the sample. Well, add up the data points. If we add up the data points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 1, 2, 3, 4, 16. 1, 2, 3, 4, 5, 6. So there are 16 in the sample. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Why do I only have 15 in my picture, but I said 16? Sorry guys, I'm counting on my example sheet. Maybe I counted wrong before. 1, 2, 3, 4, 5, 7, 8, 16. So I must be missing a data point. I'm missing 29. Okay, now there's 16. Well, what's the smallest value in the data set? Well, the smallest value in the data set happens to be the number 16. And what does that number represent? Well, what does it represent? It represents that one car that was made in 2015, one model of car, had a fuel economy of only getting 16 miles to the gallon. One 2015 model car gets 16 miles per gallon. Gallon of gasoline. How many cars in the sample get 31 mpg, miles per gallon? So if I go to 31, how many of them get 31? 1, 2, 3, 4, 5, 6 different samples of cars. Do we have any that appear to be outliers? Because I haven't taught you how to find an outlier yet. Well, an outlier is a data point, or points which appear way far away from all the others. So it kind of looks like, 16 is pretty much all by itself out here, and 40 is pretty much all by itself out here. So it looks like I have two outliers. I have both the number 16 on the low end and 40 on the upper end. Are there any gaps? Well, we have several gaps. We have a gap here between 16 and 23. That's 7 mpg. We have a gap here technically, but it's only 3 when you really look at 24 to 27. And now it looks like we have a larger gap here, which is 8 away between 32 and 40. So I would say if we have gaps, we have them between 16 and 23, between that outlier and between the other outlier and most of the data, so between 32 and 40. And then finally, do we have any clusters? Do we have any that are grouped together? And it sure looks like I have the majority of the data majority of the data is falling between 30 and 32. So I would call that a cluster. Okay, so there's an example of a pictograph and a dot plot. All right. Then the next one is a frequency table. I can do this one just live with you. So a frequency table lets you order and lets you know how frequent something is. So if you printed this out, I tried to give you a space where you could create the frequency table. So a frequency table is used to tally and generalize results. Okay. Frequency table is a table which is used to tally and generalize results of a set of data. And they can be displayed vertically, they can be displayed horizontally. I chose horizontally for space on the paper. So what I'm going to do is I'm going to give you quiz scores for a class of 20. And we want to create a frequency table. So given 20 quiz scores, total point is out of 30 points. So this would be actually a data set that I did off of a quiz in one of my classes last semester. So I have 20 quiz scores out of 30 points. Let's create a frequency table. So this time, because of space on the paper that I gave you, I'm going to make the frequency table go horizontally. And in other examples, I'll have it go vertically. So here are the scores that were on that quiz. Not in any particular order. We had a score of 21, 20, 28, 18, 27, 24, 22, 28, 30, 15, 21, 24, 27, 24, 30, 18, 20, 26, 21, and 28. And again, these are all, you can pull up the PDF so you don't have to write these all down, or you can print it out so you can. Let's create a frequency table. So on that note, on that homework set, if you printed it out to the right, let's create a frequency table. In my space, I have it right here. So what am I comparing? Well, I'm comparing all of these scores, okay, to the frequency that they occurred. So think of it this way. Okay. I'm going to list the score and then the frequency. In other words, how often it occurred. And I'm going to choose to rank them from low to high instead of high to low. So I'm going to first start off with a score of 15. That seems to be my lowest score. So how often, when I look through here, the lowest number I have is 15. And it looks like I have one of those. And then what's the next lowest score we have in our data set? The next lowest score looks like 18. How many times, how many ways, how often, how frequent did 18 occur? It looks like 18 occurred twice. Whoops, meant to be green. What's our next number? Our next number appears to be the note score of 20. How often did that occur? 1, 2. I think you have the idea. The next score is 21. Then if I rank it, the next score is 24, 26, 27, 28, and 30. So I'm just ranking them. I'm putting in order and then filling it in. Let's see, I have 1, 2, 3 that are 21, 24, 1, 2. I forgot 22, didn't I? I think I forgot to put 22 in here, so we better squeeze a 22 in here. Sorry about that. I see, I better finish my 24 though. 1, 2, 3 24s. Apparently I have a 22, 26, 1, 27, 1, 2, 28, 1, 2, 3, and then 30 should be the only ones that are left, 1, 2. Okay, so that's what we mean by a frequency table or a frequency chart, is making a chart of how often something occurs. All right, I'm going to pause this while I set up our stem and leaf so we can talk about it. Okay, so here's an example of an ordered stem and leaf plot. So it's on that second page of examples that are in your module. And we have a stem and leaf shows the ages of 30 people taking an art class. Okay, so if I add these up, now what does this represent? The stem represents the decade. So in this case, 70, 60, 50, 40, not the 1970s and the 1960s, but rather meaning this person's been on the planet 10 years, 20 years, 30 years, 40 years, 50, 60, 70. Okay? So this would be like a 72-year-old, a 61-year-old, a 64-year-old. And we always put them in order. You can either go low to high or high to low. When you order the leaf, it always needs to go smallest to largest. Meaning, if I have all these data points, I've got to put them from least to greatest, from left to right. Okay, so I have these 30 people that are taking an art class. Of these 30 people, how many of them are teenagers? Well, a teenager would be like 13, 14, 15, 16, 17, 18, 19. So I need the first part of that, the number sense again, to be a 10 and a 3, a 10 and a 4, 10 and a 4, 10 and a 7, 10 and a 9. So how many are teenagers? I have a 13-year-old, a 14-year-old, a 14-year-old, a 17-year-old, and a 19-year-old. So I should have 5 of them. Looking at our data, how many are 43 years old? Well, with number sense, we're looking for the tens place to be a 4, so that would represent 40, and the ones place to be a 3. Here's one, here's another one. So I have 2 people that are 43 years old. How many people are over 50? Over 50. Well, this leaf and stem, this stem and leaf, this stem and leaf all represent 50s, 60s, 70s. So over 50. So I don't count the 0, but I count 53, 56, 57, 57, 59, 61, 64, 72. So what do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. What's the age of the oldest person in the art class? Oldest person would be 72 years old. Are any teenagers the same age? Teenagers consist of 13, I have a 14-year-old, and I have another 14-year-old. So yes, we do have 2 which are 14 years old. Okay, so that's how a stem and leaf plot works. All right. Now you can also have a back-to-back stem and leaf plot. And actually, I don't think I want to draw this whole thing out. But what it would mean is if I had another class that I wanted to compare, I could keep the same decades and go 71, 73, 75. And I could also build it the other way. So I'm actually going to let you take a look at that back-to-back stem and leaf that I gave you. I don't know if this will show, because you can see there's a whole lot of data points that compare cab drivers. So right down the middle would be our stem, and then our leaves go off in each direction for each of the cab drivers. Okay. Take a look at that one in the module. And then let's take a look at histograms. Histograms. And histograms are used to represent frequency tables. Histograms have bars that are connected. There's no space. They represent a range of numbers. Okay, so if I have 30 randomly chosen third graders were asked how often they choose to visit the library during a time at school. All right, so here's our example. So we have 30 students in third grade were asked how often they visit the library during free time in 1 week. So first I'm going to show you a frequency table. And we just did a frequency table. But in this frequency table, this time I'm going to go vertically. So I'm going to say the number of visits to the library and the number of students. So let's say we go, okay, they go to the library, there's 1 week, Monday, Tuesday, Wednesday, Thursday, Friday. So maybe somebody, how many went only 1 day a week, 2 days a week, 3 days a week, 4 days in that week, or 5 days in that 1 week that we asked about? And our results were the following. The number of students that only visited the library 1 time was 4 students. And then we had 2 students that visited twice. 8 students that went to the library during free time 3 times during the week. Well done. We had 11 visit the library 4 times, and we had 5 visit the library 5 times. So we have our frequency table. Let's turn that into a histogram. Okay. So when we do a histogram, we always need to label our histogram and title our histogram. So I need 2 axes. Those 2 axes represent the titles of our frequency table. Okay? So I'll do on this side the number of students. And on the horizontal, we're asking how often did they visit the library. So I'm going to have frequency for visiting the library, or library visits. And then make sure you always title this. Always title it. So it could be something like, students who visit library during free time in 1 week. So now let's think about what we've got here. Well, we said we only had 5 days a week, so we could have listed this. They only visited 1 time, 2 times, 3 times, 4 times, 5 times. In other words, they visited once a day. And when you make a histogram, they're always connected. Histogram has no gaps. And the way we do this is we put the number of visits in the middle of our bar. So if I start with how many of them visited 1 time a week, we had 4 students. So we look at our range here, the largest number is 11. So I want to make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Highly recommend you do all your homework on graph paper so that you have all the lines and the graphs right there. Now when you go to make this histogram, there are 4 students who visited once. So I need to come up here to the number 4, and a lot of times it's easiest to go to the number 4 and put a little 4 there. And then you want to make sure that this goes halfway between 1 and 2, and halfway between 0 and 1. And then we create, oh good, it's perfect, roughly about the size of that. So it's about halfway. Then you go, okay, how many went 2 times? Well, it dropped down to 2. 2 is 1, 2. So I'm going to go to about here. We'll call that 2. And we already determined that it's about the width of my ruler here. It's a little off. It should be halfway between these. Graph paper would make it perfect. Number of 3 was 8, so now I'm going back up here to 8. 5, 6, 7, 8. Gotta come up here to 8. So I need to come all the way up. Gotta go halfway between 3 and 4. Again, better with graph paper because mine are not quite exactly the same. Oftentimes you put the number 8 because that's easier to read it. Then we go to 11, 9, 10, 11. And remember, the key is to keep these all connected. So these are all connected. And then we finish off with 5. Right about there. So I like to put the little numbers, it's easier to read. And that's a histogram. So they're all connected together. And then I actually showed you a bar graph in the last section. So a bar graph is very similar to a histogram, but there's always spaces between them. So I'm going to pause the video while I set up the next 2 examples. All right, so this next example is talking about bar graphs, whether it's a single bar graph or a double bar graph. So with a single bar graph, you're comparing, it's a 1-to-1 comparison. So in this example, 128 students were asked which superhero is the most brave. And in this group of 128, you can see the results. 52 thought Batman was the most brave, 25 thought Captain America, 34 thought Iron Man was the most brave, 17 thought Superman was the most brave. And let's make a bar graph out of it. Now a bar graph there's always spaces between the bars. So making a bar graph, first start with your X and your Y axes, your vertical and your horizontal. And it really doesn't matter which one you put along which axis as long as they're labeled. But the general sort of universal idea is make sure you put the numbers up the side and what you're comparing along the horizontal. So we might have, Batman, Captain America, Iron Man, and Superman. And then it looks like in this case, our range of numbers start getting pretty high. So maybe instead of counting by ones, you count by fives or tens. Again, graph paper works beautifully for this. I'm going to go in intervals of 10. So let's see if I can make this a little bit nicer here. I think I actually have quite a bit of room over here because I need to go to the highest of 60. So I'm going to go 10, 20, 30, 40, 50, 60. I needed to go to 60 so that I was past my highest value of 52. And we have to label that axis to represent what they are talking about. So this would be number of superheroes. Okay? Actually, in this case, it's kind of self-explanatory. Now make sure we title our display. Always give it a title. So in this case, we're comparing superheroes and we're trying to figure out who's the most brave. So I'm just going to call this Superhero Battle Winner. Or you might put a question mark. Which superhero is the most brave? And now with a bar graph, we need to make sure we put a space between them. And the rule of thumb is, once we create our first bar, the space between them should be half as wide. So Batman, there's 52 people. So 52, and again, I kind of like to go up and make a little mark. So 52, I'm going to switch colors. I'm going to use the width of my ruler. Actually, I can't because this is going to spread out. So I'm going to use the width of my ruler then to be the space between them. So I'm going to come up here to 52. So it should be about twice as wide. Okay, and again, if you want to, you can put 52. Now I've got to take about half that distance, and that should be the space between that and the next bar. The next bar is Captain America at 25. So roughly, if this is, in my case, 1 3/4, okay, then I need about half that space. So 7/16, so I'm right about there. I need this to come up. And look at that, it is about the width of this. Oh, nice. 1 3/4. And I'm going to make these solid bars. Captain America came up here to 25. Now I take half the distance. Remember, because we want these to be spaced out. Iron Man went all the way up to 34. 1 3/4. Oops. And again, using graph paper is really a nice way to go. Because then you can count over, you can make your bars wide, and you can make your space between them 1 wide, or whatever you choose. But I think you get the idea. And then the next one is way down here at 17. So to give you kind of an idea. Okay, so I'm just going to eyeball this one so we can move on. So a bar graph always has gaps between them, and these gaps are half the width of the bar. And you can shade them in or not shade them in, that's your choice. A double bar graph, now instead of a 1-to-1 comparison, it's a 1-to-2 comparison. So we're going to be looking at Jeff's score on a math test without studying versus studying. Okay? So let's say they're taking a fractions quiz or a fractions test. And we take it and we say, okay, let's just take the test right now on a Monday. Let's see how you're doing. And we did fractions all last week, so let's take a test. Then you go, well, you know, do you want to keep that test or do you want to go home and study and take a new test after studying? And so you can see the scores. Usually you would expect scores to go up when you've studied. Occasionally they don't, but usually they do. So I'm going to sketch this just to make it go a little quicker instead of actually measuring everything out. But again, okay, whoops. And if I were doing this with an elementary school class, I might have the axes drawn on paper for them already so that they just have to practice labeling. And since these are percentages and the highest is 100, I'm just going to estimate. I call this 10%, 20, 30, 40, 50, 60, 70, 80, 90. So here's 100% for the score on the test. And down here I'm going to have my students. And I always need to title. Always need to title. So perhaps this is representing the scores on a math test. Or a fractions test. So now you know exactly what you're comparing. And let's sort of start. So Jeff's going to go first. And then I have Paula. Then I have Marcus. Then I have Kylie. And then I have Darlene. And I'm just going to sketch these because I think you'll get the idea. So Jeff, without studying, oh, and I need to make a legend. So I'm going to let pink represent without studying. And I'm going to represent green with studying. Okay? And I'll do this one pretty quickly. So let's see. Jeff, without studying, got a 73. We got about a 73. So I'm just going to But then Jeff, when he did study, he got a 90. Whoops. So we got a 90. So what I'm doing is I'm making a double bar graph. I'm using this a little bit. Okay? So I'm using both of these. So here's Jeff with and without studying. Then I go to Paula. Now I have to have a gap between them because it's a bar graph. In this case, I'm leaving a larger gap so that all my pens don't blend together. Paula went 60 and then a 74. So I'm going to have a bar coming up here to 60 and then a bar going to 74. 50, 60, 74. Okay, and I would color them in. I'm not going to for our purposes because I think you get the idea. Marcus went all the way to an 80 and then an 84. Okay? Riley, 45 to 55, 45, and I'm eyeballing it on a test or quiz, and in reality I should be using a ruler, and I think you guys get the idea. 81, all the way up to 100. So just to save time, okay? Of course, ask me questions if that didn't make sense. So color them in, make them nice and pretty, but that's a double bar graph. Okay. And then a pie graph, I really want to do with you in class, but I'm going to go ahead and set it up here. And you will need a calculator to figure out some of the percentages. And I'm going to sketch it now, and then we're going to do one in the lab and probably in class. So you'll need a protractor as well. But for now, we're just looking at what they look like and how to represent them. So let me set that one up. I'm going to pause it. All right, and our final example here is going to be with a circle graph and how to create a circle graph. And what you need is you need your data, you need a calculator, you need a straight edge, and you need a protractor. Now the straight edge can also be found on the protractor. A straight edge is anything that creates a straight edge. Okay, and you need a circle where you've identified your center. So for our purposes, we're going to estimate a little bit. Now the sharper your pencil, the straighter your lines, the more accurate. So mine might be a little thick because my pen is not, it's a whiteboard marker, so it's not super fine. All right, so let's go through the calculations first. Okay, so here we left off with our superhero battle on which one was the most brave. And our 128 students in this high school class answered that following way. Okay, so a circle graph uses percentages. It uses part of a whole. So we want to always be thinking about what part out of the entire whole, what wedge or sector, all right? So again, I'm going to label this. This is our superhero battle winner. Sorry, I'm trying not to touch the whiteboard. I didn't want to erase the circle with my sleeve. And we need to create what are called sections or wedges. Okay, so each one of these sections we call the sector, and I'm going to show you how to calculate that. So it's a graph that uses percentages. So we need to know what percentage or what fraction of the whole, what wedge, what pie piece is going to fit in here. So here we want the fraction, we want what part out of the whole circle is represented. So how many out of the entire class like Batman? Well, we had 52 out of the 128 students liked Batman. What part liked Captain America? 25 out of the 128 students. 34 out of 128 students liked Iron Man. And 17 out of the 128 felt that Superman was the most brave. Okay. So now we need to turn that into a percentage because a pie graph or a circle graph is always based on percentages or the wedges. So let's turn this into a percent. In other words, do the division. Percentage, remember, is always rounded to the nearest hundredth. So a percentage is always what part out of 100. So we need to round this to the nearest hundredth. So if I take 52 and I divide it by 128, I get 0.406. So 0.406 would round to 41%. Then if I do the same thing with 25 out of 128, 25 divided by 128, I get 0.195. So for our purposes, I'm going to round this to about 20%. 34 out of 128 gives us a 0.265. So I'm going to round up again to 27. 17 out of 128, 0.132. So I'm going to round that to about 13%. So it's quite possible these may not actually add up exactly to 100% because we had to round. So here we rounded up, here we rounded up, here we rounded up, here we rounded a little down, so it might be a little over 100%, but it's close enough for our pie pieces. Okay? So now at this point, we need to figure out how large each wedge or each sector is going to be. So I need to know the degrees for each sector. The sector is the wedge, the pie piece. Now there's 360 degrees in a circle, so I want to know what part of the circle do we have here? I know I have 41% of the circle, so I need to take the percentage. Okay, so take your percentage and multiply it by 360 degrees to come up with each wedge or sector. So if I take my 41% and I multiply that by 360, if I take my 20% and I multiply by 360, if I take my 27, it's going to be more accurate with this number, and I multiply by 360, and I take my 13% and I multiply by 360, we're going to get the percentage of the circle we need, how many degrees. Okay? So if I actually take, I'm going to be much more specific. I'm going to take my actual 0.406 times 360. I need 146 degrees. Wedge piece, if I take 0.195 or 20%, 20% of that circle is approximately, I'm rounding it to 70 degrees. If I take 26.5 or that 27%, whoops, just 0.265 times 360, I need a 95.4 degree angle. And lastly, I get about a 48 degree angle. Okay, so these might be a little bit off. If I add them all up, I might get something a little larger than 360 because we had to round. So I'm going to start at the beginning. I'm going to start with a 146 degree angle. Doesn't matter where you start. I'm going to choose to start, actually to show you guys, I'm just going to start my center. That's going to be the vertex. So I'm going to line up my 0 degree line of my protractor right at that center. Since I need 146 degrees, I'm going to come all the way around on the outside of these numbers to 140, and I have to estimate at 146. Open up my protractor, and remember, please, I have a thick pen, so I'm trying to estimate a little bit. So right here is 146 degrees. So this is 41%, and it represented Batman. Then I'm going to break off of there, and I'm going to go to, I'll do blue for Captain America. Captain America, I need a 70 degree wedge. So I'm going to just go off of where I was before. I'm going to use that for my 0 degree line, and I'm going to use my outside numbers 10, 20, 30, 40, 50, 60, 70. Combine the center to that. So this wedge is a 70-degree wedge, 70 degrees, 20% rather. So this 20% represented Captain America. Let Iron Man be green. Green was 95 degrees. So again, measure this using the 0 line on your protractor. 10, 20, 30, 40, 50, 60, 70, 80, 90. I need 95 degrees. So it should look almost like a right angle. That's pretty close to a right angle. This represented 27%, which was Iron Man. And then if I measure the last angle, it should be about a 48-degree angle. And mine turned out to be just a hair like at 50. So it's not too bad for estimation. And I will put Superman over here in baby blue. So Superman is 13%. Okay, so we have to do a little bit of calculations. All right, so that takes us to the end of 10.2. 10.3 will continue on this same document of examples, and we'll take a look at that next time.